So we are now on to level 10, which is all about conic sections. So I know this is changing up your book a little bit, but I think doing conic sections next ties better with what we just finished up with parabolas, than moving on to more complex polynomials. We will get to polynomials, but first, conic sections. So you may have seen this before, and that's okay. We're going to do a little bit more with conic sections. So what that means is you start with a cone. Here we have a double cone. And all you do is you make an X, you spin that around. In order to get our 4 different conic sections, if we slice through an endpoint, one part of our cone, we get the shape of a parabola. If we slice horizontally, right through a cone, we get a circle. So that's where circles come from. If you slice through a slant, but it's not through the base of the cone, you get an ellipse. And if you do a vertical slice through both sides of this double cone, that's how you get a hyperbola. So these are the 4 shapes that people have been studying since ancient Greek times. And I decided to put some of the basic vocabulary on the bottom of this. And so we need to know where our center is. All right, we know how to find a center. We're going to find out what the vertex means. So with parabola, we've already experienced a vertex. And we called that h comma k in a parabola. The vertices of a ellipse or a circle or a hyperbola are their endpoints. So we have different definitions for what a vertex is based off of what the conic section is. The focus. So each one of these shapes has a focal point. And that's a very big concept with conic sections. So being able to find a focus or a foci is how we build these shapes by hand. Also a directrix, so that is crucial for a parabola. Axis or axes, so we will have a major and a minor axis for an ellipse and a hyperbola. And you could say a circle would be the 4th, but a circle is just a special case for an ellipse. So then that's what we get, major axis and minor axis. Major axis just means the longest side or the longest axes, and the minor axis is the shortest axes. The last set is the locus, which we won't really be focusing on, but I wanted to present that word to you guys so at least you have seen it in your lexicon. So that's all 10.1 is just presenting this information of what we're about to study. So if we move to 10.2, that's the first section, and that's parabolas. So level 2, we are talking about the parabola here. So I will read the definition and then try to translate it as best I can for you. So a parabola is the collection of all points in the plane that are the same distance away from a fixed point F, which we call the focus, as they are from a fixed line D, which we call the directrix. So F is the focus and the line D is the directrix. So what does that mean? And how did people start studying parabolas? Well, if you just take, let's draw our graph. Let's say we pick a fixed point and we say that's F. And we draw a horizontal line the same distance away. If I construct a graph, these 2 points, this point is equidistant. And if I draw my parabola, if I found the distance from here to this point, it would be the exact same as the distance from this point to my line. So there is some point here that are equidistant all the way. So if we did equidistance, 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 that's how you can construct a parabola. So we called this line here the directrix, and we will write that as, this is a horizontal line, so y equals a, negative a for our case, and this point here is our focus, and that is a units away, so that's up, so 0, comma a, we would go up from our vertex, and our vertex here is at 0, 0. So we're going to first start looking at the origin, and that's what this means. So equations of a parabola, a vertex at 0, 0, focus at a, comma 0. So a is going to be our distance from our vertex to the focus, and then negative a will be the distance from our vertex to our directrix. Okay, fancy words, but really super simple concept. So we're going to start with this equation. Y squared equals 4ax. Now, everything we've done before has an x squared on it. So what is the difference with x squared to y squared? Well, it's the orientation of our parabola. Everything else stays the same. So what does this graph look like? Where is the focus, and what is the equation of the directrix? So if we have something with y squared equals 4ax, our focus is A, our vertex is 0, 0, because we can still go back to h, comma k, which is 0, 0. We have nothing there. So we start here. Y squared means sideways parabola. And if it's positive, it goes to the right. If it's negative, it goes to the left. So we're going to have a sideways parabola that is, let's call this some distance a away, and that's going to be our focus. And if we go the same distance, doesn't have to be 4, we have a vertical line, so that would be x equals negative a, and that is our directrix. So then our parabola would look something like this. So that's how we get a sideways parabola. And notice that the focus and the directrix are the same distance away, just in opposite directions. So let's try a couple. Find the equation of the parabola with vertex 0, 0 and focus at 3, 0. Graph the equation. So if we start this off, our h, comma k is 0, 0, so we're at the origin. Our focus is at 3, comma 0, so that's our a. Our a equals 3. So if we wanted to write our equation, and we notice that this is 3, comma 0, so that's going to be a sideways parabola. If it was 0, comma 3, that would be a parabola opening up. So this really is our key to figuring out what the orientation is. So we're going to have y squared equals 4 times 3x, or y squared equals 12x. That's our equation. So now we're going to draw our graph based off of that equation. So our vertex, which we're going to label, is v. If we go 3, 1, 2, 3, that's our focus. And if we go 1, 2, 3, that's our vertical line. And we know how to write the equation of our vertical line is x equals negative 3. So that's our directrix. And then our parabola. Now, could we plug in points? Absolutely. Are we just trying to get the rough shape of this graph? Yes. So that's our vertex. And that's as simply as you can do it. That they give you the focus and the vertex. Let's try another one. Analyze the equation y squared equals 8x. And just as a note, whenever you see it says analyze, that means find the vertex, find the focus, find the directrix, and graph. Okay, so let's first find out what a is. A equals 4a equals 8. We take that number here, and if you look back up here, that's 4ax. So 4a times 8, so a equals 2. Okay, this is a sideways parabola. And how do you know? You know because it's y squared, and the a is positive, so it opens to the right. Okay, so that's a. So our vertex is going to be at 0, 0, because we have no stuff in between. Our focus is going to be at 2, comma 0, and our directrix is going to be the line x equals negative 2. Okay. How did we get all of that? All from our a. Could you also get that once you graph it? Absolutely. So just to keep it in color. There's my vertex. If I go 1, 2, there's my focus. And if I go 2 the other direction, and I draw my vertical line, that's at x equals -2. That's my directrix, and my parabola will open sideways. It always includes the focus. So if you can find where the focus is, it tells you what direction your parabola will go. All right, let's flip it over. Okay, so we can see this big table now right in front of you. This tells you if you give the vertex at the origin, how can you tell where the focus is based off the equation? So if you have a positive a and a y squared, that means it opens to the right. So opens to the right. If you have a negative a and a y squared, that means you open to the left. That's the key. If you have an x squared and you have a positive a, then that opens up. And if you have an x squared and a -4a, that means you open down. Mind you, all of these are centered at the vertex, at the origin. We will be doing some shifting around, but this is the starting point. So again, you can see each one of these. A is here, B is this equation, C is this graph, and D is this graph right here. Okay. So example 3, analyze the equation. So first off, we see this is an x squared, so this opens up or down. We see that that's -4a, so this opens down, just based off of looking at this. There's an x squared and a -4a, so then we're going to say 4a equals -12, or a equals -3. So that means if we draw our graph, our vertex will be at 0, 0. So vertex, it's really important that we label everything. So the vertex is at 0, 0. This -3 means I go down 3. 1, 2, 3. That's my focus. So my focus is at 0, -3. My directrix would be 1, 2, 3, and it would be a horizontal line. So my directrix is y equals 3. See how these are opposite? And now I know that this opens down, and we want to include the focus. So there is my parabola based off this equation. Same thing. Find the equation of the parabola with the focus at 0, 4, and directrix of the line y equals -4. Graph the equation. So these should be your two keys. Your a is 4, so my focus, see how it's 0, 4? Our focus is going to be at 0, 4. Vertex is going to be halfway in between. So if we plotted these points, we go 1, 2, 3, 4. There's my focus. And if I went 1, 2, 3, 4 and drew my horizontal line in, that's my directrix. That's y equals -4. So my vertex has to be halfway in between these two, which means my vertex has to be at 0, 0, because it's halfway in between. So my vertex is at 0, 0. Then to write this equation, we know that this opens up. So that's going to be an x squared equals 4 times 4y. Because our a is 4, and the equation that we're going to write for these is 4a times y, or 4a times x. So that means this equation is x squared equals 16y. All right, flip it over. All right, example 5. Find the equation of the parabola with the vertex at 0, 0 if its axis of symmetry is the x-axis. Okay, so that's calling back what we should know. Our axis of symmetry is the x-axis, and its graph contains the point -1/2, 2. So it's really important that we write down each one of these pieces of information. So vertex at 0, 0. So our vertex is at 0, 0. And if we graphed this, so 0, 0, negative 1/2, 2 is a point. So negative 1/2, so negative 1/2, 2 is a point in our graph. And our axis of symmetry is the x-axis. So we could use this axis of symmetry to show that we have another point at negative 1/2, negative 2. So our parabola is going to be sideways. So how do we figure this all out? Well, if we know that this is a sideways parabola, that's going to be y squared equals 4ax, because that's with our vertex at 0, 0. Now we just have to find a. So we're going to plug in this point to find our focus. So y squared, which is 2, equals 4a times negative 1/2. So I have 2 equals 4 times negative 1/2 is negative 2a. So a equals negative 1. So that means my focus is going to be at negative 1, 0, which makes sense with our graph. And my directrix would be the opposite. So that would be at positive 1. And that's going to be the equation of a vertical line. So the way you write the equation of this vertical line is x equals 1. So we found the focus, the directrix, and we graphed it. So what happens now if we shift this away from the origin? Well, it's nothing new. All we're doing is introducing an h and a k. So if we look at our equations, we could have a sideways parabola with h and k. H always goes with the x, k goes with the y. We could have a sideways parabola that opens to the left or to the right, or we could have a sideways parabola if we have the x squared that opens up or down, moved h or k. So all we have to look at is what variable is squared, and then what's the value in front of the non-squared term, because that will tell you which direction it opens up. That will tell you where its focus is at. Okay? So if we want to see, this first line is this graph, a sideways parabola, moved up or to the right h and up k. Same thing here. If we move it hk in some direction, that negative a is going to change the direction, so it'll open left. C, we have an x squared term, so we have x minus h squared, and then that opens up because the a is positive. Likewise, hk moves our parabola. The negative in front of the y changes the direction, so it opens down. So we have one more page, and then we are done with the first section of level 10. So example 6, find the equation of the parabola with the vertex at negative 2, 3. So let's write that down. Vertex at negative 2, 3. Okay, so that's our first thing that's different. And our focus is at 0, 3. Okay, so that's another really interesting piece of information. Let's first graph this and then come up with the equation. So if we go to our graph, we go negative 2 and then up 3. 1, 2, 3. Label your point. Our so that's our vertex. Our focus is at 0, 3. So our focus, if I do that in a slightly different color, is right here. So if we see, we have a sideways parabola that opens to the right. So we are going to have y minus k squared equals 4a times x minus h. Well, we already know our a is 3. So plug in our y value, so that's y minus 3 squared equals 4 times 3 is 12, x minus a negative 2. That's our equation. We could also put in, if we know this is 1, 2. Oh, sorry. Ignore me. How far away is the focus from the vertex? We can just count. 1, 2. So our A is 2. So we really have to look at our vertex to our focus. So if our A is 2, that means this number is 8. Sorry about that. So that means if we go 1, 2 to the left, we get our directrix. Let's see if that's just about there. And the equation of that directrix is at x equals -4. So we have our vertex, we have our focus, we have the equation, and we have our directrix. Now we just have to graph this, so that means we have our parabola that opens this way. All right, example 7. Analyze this equation. What does analyze mean? Find the vertex, find the focus, find the directrix, graph it. So let's first look at this. We have an x squared and we have a 4y. So first thing, get the x squareds and the x's all on the same side. We're going to leave a little space, equals, add 4y to the other side. We are going to complete the square here. So half of 4 n squared is 4. Whatever we do to one side, we do to the other. So we add 4 there. So this is x plus 2 squared equals, we're going to factor out a 4, y plus 1. So our vertex is at -2, -1, at h, k. Our a value, our 4a equals 4, so a equals 1. So we know that this opens up, so that means on our graph, our vertex is at -2, -1. We open up, because this is positive, so we go 1 up from our vertex, we get our focus. And let's see what that ordered pair is. That ordered pair is -2, 0. So our focus is at -2, 0. We added 1. So our directrix would also be 1 away. So that's our line for our directrix, which is at -2. So y equals -2 is our directrix. Y equals -2. Let's just write that clear. Y equals -2. This opens up, so take this up this way, up this way. There's our parabola. So what should we know from this section? So, in order to find our focus, which is really the new thing that we added, it's always going to be our number in front equals 4a. So our number in front equals 4a. We can solve for a. Another thing that we should know, the focus is always included inside our parabola. And then I would say the focus and directrix are, fancy word here, equidistant, distant from the vertex. So this is our analysis of a parabola in terms of conic sections. Good luck with the problems.